Welcome to Tech at Lunch, the podcast that satisfies your hunger for all things tech while you enjoy your midday meal. So grab your sandwich, tune in, and let's dig in. Hello, Nick.
Hello, I'm Ed.
Hey, I'm John.
And, last week you heard us kind of talking about, SouthTech. We were, answering the, questions about, what was it, how it was and stuff like that. Stuff that, John came up with and, stuff that he was curious about because he, wasn't able to attend. So we kind of had to, I guess bring him there virtually. Kicking and screaming and kind of, crying at the end.
Not curious.
Yeah.
Not crying.
But, the thing is...
9 hours in a day. Yeah, I guess. So I was sad and not enough to look at. I couldn't get to go there and go to work, too. So.
Yeah. Well, maybe in I know they're bringing SouthTech back in 2025. So that'll be the next kick. It's kind of like Automate, because Automate's coming this year or next year to up into Chicago. It's not a SME convention. But, we are bringing back our favorite show or one of our favorite shows, I can't say our only favorite, is Rapid. Rapid's coming to Anaheim in April. And, I'm pretty sure if you talk to us enough, we'll definitely be there and walking around seeing people and saying hello. Kicking and screaming or doing whatever we got to do. But, this week we kind of want to we've been to 2 shows this year through SME. And, got to talk to a lot of people, a lot of folks we didn't even know worked together, by the way. Small world. And so we went to SME, with SME, we went to, Rapid, and we also went to, SouthTech, in 2023. But, like I said, we didn't know some of these companies work together. For example, EOS, Matter Hackers, a couple of these other guys all work with Philips, and Philips works with Haas, and Haas makes the hybrid drive system. That's pretty damn cool.
And
Melt.io. Well, they partner with Melt.io, and we saw Melt.io at Rapid. Mm-hmm. So, this conversation that we're going to have tonight is going to be, we're going to focus on STEM, but we're also going to focus on the different conventions. So we're going to do a convention compare between, at the STEM level, maybe deal into some other things between, Rapid and between, SouthTech. And we're going to kind of go over some of our favorite things we saw that really could get people kind of interested in it, and stuff like that. I know you've heard us ramble on about a couple other things before about some of these shows, but, hang on and we'll bring you right back around again. So, we're talking about that. What do y'all think?
This is definitely going to be harder for us, I guess, because we didn't get to go to... I went to Rapid, you didn't go... You went to SouthTech, so I didn't go... We didn't get to go to the conventions we each saw, on the other hand.
Nick went to both, so I think
he's the one that decides how it goes, but
oh boy.
If you... Like, for me, STEM learning is... when I grew up, it was kind of severely lacking. We didn't really have a STEM program. There was like math and there was sciences, but
can you explain? Like, can you just give an example of like when you say math and science? Can you like
the early 2010s was a rough year.
No. What I mean, like, so I'll give you an example so that you understand why I'm asking. What type of example to explain to me?
What type of math? I'm like,
so my grandson right now is in 2nd grade.
Okay.
And basically they have a vehicle that's programmed by squares. And when you put the car on the squares, it looks with a camera on the squares. Mm-hmm. And as long as it's on the squares, it just goes back and forth on the squares. So that's one of the things that they're doing right now with STEM.
Okay.
So I'm assuming you had some type of projects, maybe not like that, but there was something that you did when you talk about the science, when you talk about the math.
We had, there's science fairs every year, and you always have your science fair project. But to the projects that you're talking about, where I was actually going and saying, all right, household objects, drop this egg. Who drops the egg from the highest, with the egg being the safest, with just household, whatever, like Q-tips, cotton balls, whatever you have around, or you make a kite with, classroom stuff, some like things like that. So that didn't happen until I was in high school.
So I guess so. What?
Charge on it.
So I guess what I'm asking is we getting there. All right. So I'm saying when you're in STEM, say middle school. So you had STEM in middle school.
No. There was no actual if you say
STEM curriculum.
there was no STEM curriculum focus. There was always the science teacher was just very enthusiastic about it.
I
right?
understand that. Okay.
So they would eventually, you're based on curriculum. Like they submit their curriculum at the beginning of the year, and if it's just worksheets, a lot of it was just worksheets. And that's not very.
I follow you now.
Yeah, so when I boil it down to that, I look for anything that's hands-on. Not all kids are going to be hands-on learners. So when we talk about STEM stuff, if you've got something that is, either intuitive, easy to learn for like a younger generation, or something that's like just looks fun to do, is like moving the robot around, printing something big. That looks fun to do. Not always very glorious, but at the end of the day, it's something that like would attract me as a STEM learner or something like that. So for me at Rapid, I saw every booth had a robot, and if it didn't have a robot, it had a video of what its machine did. There's a lot of additive. There was subtractive cleaning. There was making polymers, making the materials. There was so many things there that yes, everyone had the passion about it, but less so. They were just like, hey, here's a little trinket to remember me by. And that to me isn't as impactful as, hey, okay, come on over here. These are all 3D printed. Here's a TPU printed ring. These are all 3D printed vases. Get one vase. That's 10 points on this row. You get extra points in the back, and then if you get the highest score, you can win a printer to print things like this and make this game at your house. That to me is more impactful, and I guess that's the word I'm kind of getting towards, is making it impactful. Of course, at the conventions, you see everyone they want you to buy their product. At the end of the day, that's how they keep the lights on. They sell these things. But if we're talking STEM, what is the push or the focus to that? I would say there wasn't enough. They talk about a lot of they talked about the business exploding to the billions. It's going to be worth quite a bit. The focus on the youth, they had kids there, so they did have. The there was day. The bright minds. So there was something. So maybe they just kept it separate, and we didn't get to, be there because they wanted to keep the kids with their classrooms. But at the end of the day, I don't think that 30 or 40 kids is going to fill the void that we've already talked about with the job market in these specific. It's a new industry, so they're going to have to work hard to fill the current positions, and then if these guys want to focus, they can get into additive. I think that additive is just going to continue to grow because it just makes sense. Let's say down the line we end up on Mars. You're going to be doing additive manufacturing on Mars too. It's going to be the quickest way to get projects up and things produced. You can't do injection molding like that. You can't set it up and do a station like that. So we saw a lot of focus on those. I would say that I did see a lot of universities there too. So
that is true.
I'll get a little bit into what some of those universities were doing a little bit later. But there was about 4 or 5 schools there that were actually. So I'd say on that level, yes, I think a focus is there. But I think that the formative years, like the 5th to the 8th to maybe even 9th grade, kids are not getting the focus that I would say is necessary right now. So those are going to be the next generation in the workforce now.
Which is funny because when I was in 8th grade, when I was in 8th grade, we had to take we didn't have to take it, but we took it. Was a technology class. It was one of our periods we'd rotate through into, and we'd go into this. We would learn computer programming. We would learn bridge design. We would learn basic engineering and stuff like that. And then we would work as groups to build the strongest bridge.
Oh, I wish I did that.
And it would be a trestle style bridge. Sprung over 2 points. And what they would do is you'd hang a weight from the middle, and you would see how long it would take till the bridge cracked, and shattered. And you would build, and the thing is, it wasn't just that project. We'd find other projects to build things and stuff like that. And you would cat them out on the mission, on the computers, and kind of get, kind of what's going on. This is down in Florida, so not all states are the same. So not every state wears the same.
So hold it.
Keep
going, but don't talk much more about Florida because we're gonna come back to that.
Florida man.
Nothing.
Stop mentioning Florida.
No, because it's a reason. Because I have a point.
Oh boy.
So so each states are different. You are from Florida.
Yeah.
Nothing's wrong with Florida, guys.
Yeah, well, not all the time. But the thing is, we did it the same. We did the same thing in 6th grade. You had to take a typing class. You had to get it. You had to hit certain milestones.
Okay, I will say I had a typing class. Yeah.
But the thing is we focused on how do you modify that, and stuff like that. So we kind of went through that part. And so, as things shifted, you kind of see that everything's coming back around. Every show we've been to has had a Bright Minds, theory set into it because that's what SME is. SME sets up these Bright Minds. Nonprofit organization to bring the kids in and see everything. However, I think the big topic, when it came down to, for example, I guess the difference between rapid and between Rapid and South Tech is South Tech also brought in the Titans of CNC students to come in and kind of see everything.
They had their own little classroom of
you see them all working on shirts because it's the thing is that the schools were pushing it.
Yeah, see, and that's the thing. That's the piece there that so I would say. Growing up in North Carolina, in Robinson County, which is one of the poorest counties, not in just North Carolina, but in the country, we had to choose between having a football, basketball, baseball team, and having an art band and ROTC program. So we couldn't have both of them. We had to start cutting sports out.
Yeah.
At a certain point, so
which is weird because we were forced to take art,
which is tough. Yeah, and that's the thing is and there wasn't enough focus on the STEM side. So to me, yeah, there was a lot of kids in North Carolina. If you go up around Raleigh, you got the focus on STEM. Especially in the Durham area. But growing out, it was cornfields everywhere. So pretty much out there, farmland, they really didn't focus on a lot of
Nebraska.
It, and they're lacking. To be honest with you, they're if they used any type of the technology, the STEM, the smart sensors that we talk about now that we use today with our little rinky-dink Ender 3 robots, it would make their efficiency skyrocket. And the one thing that I can say is that their harvest isn't always great.
Yeah, which is kind of funny because y'all have a lot of ag type machinery as far as being manufactured in North Carolina.
Yeah.
And that's
John Deere, Caterpillar out there.
Yeah.
Well, they manufacturing it but not developing it. That's the difference. That's what I wanted to touch on with North Carolina and Florida and Alabama. Here's the difference when you start talking about STEM. STEM for you was different from STEM for me. We didn't have somebody dedicate a program to STEM. When I was growing up, I had a Radio Shack 101 electronic projects. That's how I learned electronics. Also, I had Popular Electronics, a magazine.
I remember that. I had that too.
That was my STEM. Also, at that time, you had stuff like Star Wars and Star Trek and things of that nature. So it made you think. And so I think with all of us, Orlando is how far from a NASA facility?
Where I grew up in Oviedo, Florida. I grew up about 30 minutes from Lockheed Air and Space, their headquarters in Orlando. But from where my house is to, say, Launch Complex 42, on board the the Air Force Base, or now Space Force Base, I guess you could say, is right at an hour and 15 minutes. So we were watching space launches from my backyard. We watch those daily. We grew up, everybody, shedding a tear when, the reentry of Columbia happened.
Yeah, it was sad.
And cheering on when Atlantis took off, following the tragedy. And, it's always funny because when you see, hate to, you harp on the fact, Floridians, but when it comes down to like going to Kennedy Space Center where they finally finished the Atlantis thing and Atlantis opened up, people teared up because it's something that reminds everybody of why we're here.
It's huge. It's magnet. It's beautiful.
And around there, you also have high schools that are sponsored by NASA.
That's
and they're things. But that's mostly towards getting to like Titusville area.
The point is you had NASA, which focuses on science,
like a driving force
technology,
behind it. Yeah, you're right.
engineering, and mathematics.
Yeah.
Whereas where I'm from, the biggest industry when I was growing up was timber.
Mm-hmm.
So forestry was the biggest industry.
That makes sense. No, you
Textile.
put ag. I'm gonna be honest with you.
Textile and agriculture was one of the tobacco.
Yeah.
And textile was two of the biggest things in North Carolina.
Yeah.
Mm-hmm.
So they
huge
focused
agriculture state.
they focused their teachings towards those fields.
Right.
And I think that's why you see a gap in some of the STEMs because it's based on
geolocation.
Yeah, exactly. That's the point I
No,
wanted to make.
yeah, and it does make sense. We'll get back to the conventions eventually, but
Yeah.
it does make sense because when you talk about that, when you mention it, no, I didn't have STEM growing up until I had an eccentric like geometry teacher who was like, "You're in an honors class. You need to do special stuff, right? That's fine. Like, show me the hard stuff. That's why I'm here, right? And I'm not here just waiting for the
honors kids.
The honors kid. I was, so that's fair. That's fair. But then on the same side of things is ag. Being in Future Farmers of America, 4-H club, like those things were the hugest. They got all the funding. So you're absolutely right. Whenever I was talking earlier about the sports we're talking about getting cut, they never talked about cutting the agriculture department.
Yeah.
Not even a single second. So yeah, I mean that's crazy to me that like I've never really thought about it, but yeah, it's all around me down there.
And that's why STEM is different everywhere.
And it's kind of funny because you
But
know
they
like
can still use STEM.
Right. It's like like my high school. My high school, they used to have a 4-H club. It's gone by that point.
Yeah.
But you still have a shop class. You still have an auto tech school, which is one of the top ones in the area. You have an RTC program that's constantly leading the state and parts of the nation. But you also have all these other, robotics programs and stuff like that through, the space, like astronomy club and, all this stuff. It's like, but, then you start getting like inside the ROTC program, for example, that's where I kind of, hadn't held my hat when I wasn't playing football, is, we had a flight sim program, where we were working on the flight sims. We were working on weather data, the stuff you kind of learn, you try to learn on your own because it's what you got. But it's kind of funny because, my high school was not nowhere close to being the most STEM related. We were the most sports related. However,
well, it's unfortunate. It makes money.
You get out to Titusville, like Titusville High School, for example. Titusville High School is right by. I don't know if you're familiar with Knights Armament. Knights Armament makes the M110 squad designated marksmanship rifle for the United States Marine Corps. They're a huge company in Titusville area. However, that's beside the point. That's just where they're near, so it kind of gives you an idea when you talk about retractive like CNC type of stuff. That's why they're there. But Titusville High School is directly partnered with and working through through NASA. There's some other programs there. We also had magnet high schools where you had like, science, magnet. You also had a health magnet program where people would work through that entire high school and by the time you graduate, you're a certified nurse or something. And same thing with your own, like in Titusville High School was like the advanced studies magnet where you would go to learn like rocketry and engineering. It was the engineering magnet school.
Mm-hmm.
And you would learn everything from additive manufacturing to subtractive manufacturing and partnering with, for example, Knights Armament and those other companies in the area, along with NASA, and you would work through their processes and procedures and kind of work through how they do things.
Yeah.
You know, and you're still within earshot of a rocket launch any day of the week. I remember in school, you know, the teachers would put up on the board and say, "Hey, we got a launch today," and everybody run outside and watch the launch in the middle of the afternoon.
Yeah.
Like we'd drop everything we're doing and go sit outside and watch a rocket launch.
Yeah.
You know, because it's clear as day. You can see the windows.
Yeah. So like I was saying,
wall.
I mean, I kind of took us down a rabbit hole, but I took us down a rabbit hole for a reason to do a comparison and contrast between when we talk about STEM, based on what John was saying, you know, about what exposure he had in his early years of school and what exposure he saw far as coverage at, you know, when y'all went to Rapid. So what I saw at South Tech was different. What I saw at South Tech, it was still sparse, like you said. But there was a company there that had a focus. There was a few companies. SME leading the way. But, you know, Yaskawa had some really impressive stuff that they were doing to try to promote STEM in the area they are from. You know, so I saw them saying, "Hey, we use this to train
teach
kids." I saw kids when they brought them over there, how they explained to the kids when they had a virtual application and a real world application of robotics. So there are companies out there that are focused and have a passion for, or I would even say if they started a charter for STEM, you know. So that's the reason I took us down the rabbit hole. To show, hey, it depends on where you are. So in that particular, when you go to Rapid, right now Rapid's focus is, like you said, it's a lot of stuff with
They're just trying to grow the industry.
Yeah.
Well,
What's cutting edge right now too? Yeah.
That, but it's advanced material. It's
Material
things,
science.
It's things that we can do in space. It's how can we take this application here and rapidly do prototyping. So their focus is a little bit different from what I saw at South Tech.
Yeah.
South Tech, part of it had a different focus.
Okay.
And
okay.
it's like I look at both of them because, you know, I got the opportunity to go to both, and it's, you know, absolutely it's night and day between the two. You know, unless it depends on the conversations, the sidebar conversations you're having. There wasn't very many, hey, look at this. You know, there was some people at booths at Rapid that was explaining how things worked. You know, that it really gave you hands-on and kind of showed you. But it also, you know, that's the first time where you really see a 5-axis machine, like a KUKA robot, that's doing, or an ABB robot doing 3D printing. You know, but it's not one where it's the, you know, you're like, oh, you know, let me play with this, like we did with the CAD CAM guys, you know, where you have hands-on demonstrations. Some of the stuff you did, but the thing is, you got to remember at Rapid, you have a lot of stuff that deals with heat. You know, and like what we did with it, you know, it's not as controlled environment as what you would have at, you know, South Tech, because everything is in a controlled environment. But the thing is you still have people there who was willing to talk about the material science behind additive manufacturing and stuff like that, of how we got to that point. For example, one of those being the Wilson basketball from EOS, which EOS, ironically, partners with our friends over at Philips.
And the basketball, a version of the basketball,
small
showed
one.
up at South Tech.
Yeah, a very small one did. But the thing is, you know, they were there. The finishing guys were there that you talked to, and you kind of walked your way around. You know, what type of material and type of dimension, and those guys, you go through that process, and it really, you know, you start, okay, cool, this is what we can do with this type of stuff. And you get to play with the basketball, you get to shoot the basketball, you get to really get your hands on the basketball. And you don't really think that's 3D printed because it has the same exact weight as a regular basketball, same bounce, same everything, same sound.
But you didn't have to put air in it.
You don't have to put air in it, right? It's the Populous basketball. You know, it's great for, you know, I guess you could say one-on-ones and, you know, backcourt type of games where, or given to kids, because kids get to, you know, and they're destructive when it comes down to, you know, like balls, like soccer balls, basketballs, footballs, any of that
You don't
type of
have
thing.
to, if you don't have to pump it up, that's you taking
Right.
a
Here,
step out.
let me blow your mind. I have a craft that's orbiting a planet, and I need to get something to deploy to the surface of that planet. I use some material that has certain properties that I 3D print inside of this vessel. I release this vessel with something to deploy that to the atmosphere. I let it release, and because of the properties of that material, when it hit, that property absorbs all of the shock that happens, and you get no damage deploying that particular device by just dropping it out of the atmosphere.
That's what we used to do with rovers on Mars, but it was
They have
balloons.
Yeah, they have different wheels too on the rovers too. So they're thinking about absorbing and being able
Yeah, I
to
just mean
go
just-
around obstacles.
Right.
Just imagine if you can do that, and still they use chutes.
And
You're
then
still using chutes.
Yeah.
But imagine if I didn't have to have the weight of the chutes, and I can use the technology that was used to make that basketball to make a protective
Rocket's
sphere.
gonna bounce off the planet.
ricochet.
It's like,
But
you
it's
don't
like,
need to slow it down.
you know, we still
You
had
don't have to because of gravity.
we still had the bright mines at
I'm not gonna be in
Rapid.
that play.
Yeah, really.
I'm not gonna.
Well, here's the thing: we know it works because it worked when we did the balloons. We know for a fact it worked
You're
on
saying
Mars.
slow the descent and then let it bounce and absorb, but I was
I
saying
don't mean
don't
like-
use anything.
I
and
say
you let
it's
it
in
bounce. I'm
You
just
have, so
making
let's
money.
clarify so we don't get down the rabbit hole too far. You have
Everybody's
to
turning
you
human-
have to
human ping
go
pong balls.
into the atmosphere of that planet. Once you're in the atmosphere, instead of having to land that craft on the ground, I can get that craft in orbit. It can in atmosphere. It can stay in the atmosphere and fly around the atmosphere, and I can still deploy whatever device from the atmosphere. That's the ideal. The science behind it, don't know. But the dreaming, hey, I got you.
Future dreamers.
Hey, tennis ball.
That's what they called his generation. They called them the dreamers.
I was just saying, you're bouncing off the surface. You're gonna bounce and then go back into space.
Well, remember they did call Ed's generation the dreamers.
Yeah.
So
You know how far the atmosphere is. You know what the height of the atmosphere is.
Well, I don't mean outside the planet. I mean you're inside.
No, so you're in the atmosphere, but yeah. But
So
like,
let's
what's
do it
the-
different. You have penetrated the clouds. You
Yeah,
want
no,
the
I
item to
understand.
stay in the clouds. I have made a material that has no problems with gravity because it counteracts anything that you got with gravity on any planet you want to pick, based off the material science.
Boy, Pluto would be fun.
Okay, Pluto's not a planet.
We don't.
It's
There's not enough time in the day for this conversation.
It is what they call it.
It's a gaseous state.
No. They call it. What did it?
It's a
once
gas-
we
it's a
demoted-
gas
What are you
giant.
talking about?
When we demoted Pluto, what do we call it when we
It's
demote
a dwarf.
planets? It's a
star.
dwarf
star.
It's a dwarf planet.
Yeah.
Yeah.
But
So-
this is a much longer conversation.
Oh, we're
because
gonna have this.
There's multiple forces
Yeah,
that
but
you're
the thing
neglecting,
is-
and that's not how physically things
Yeah.
exist.
So, but
How you figure? Explain to me
Oh
how
my
you
God.
could.
I don't have to explain
astrophysicist.
friction.
I didn't
drag.
say that what you saw somebody bouncing and shot into a goal is what it was. I said a material
Yeah.
that has the property to absorb forces. So you make a material.
Law of conservation of mass.
What I'm saying, if
Where's
I
it
make a
going?
material, if I make a material to absorb force, just like we do with structures.
Yeah, but where's it going? It's not absorbing it and keeping it. Otherwise, the potential. There's a difference between potential energy and kinetic energy. It's absorbing the kinetic energy and becoming.
So I
potential
say it this
energy.
way:
Where's the potential
what I
energy
just
go?
told you will happen. What I exactly just told you will
Yeah.
happen one day.
No, I'm not
Exactly,
saying it wouldn't
exactly,
happen.
and it's not gonna bounce off the planet.
I'm telling. What I'm asking you is where's the energy going? Dang it!
Thank
Well,
God
it
he's not
has
in
to go,
charge of
it has to
humans.
absorb. It has to absorb and go somewhere.
It's got to go
Yeah.
somewhere.
So, but I'm saying is if we're talking about taking a basketball, oh yeah, we went down a rabbit hole, so you're gonna deal with it.
yeah.
So if it's a basketball, then of course there may be some. It hits, the energy bounces, does not actually go all the way through because it's solid. It is transferred back into that, and that energy is
Please, for the love of God, never be in charge of human space flight.
really.
He's like, listen, guys, you're gonna hit the ground pretty hard.
Did you
But
not
you
see
can
when the
bounce
Mars
back
rover?
up.
Did you not see when the Mars rover was Did it hit and just stop, or did it bounce and then stop?
It depends on which one you're talking about.
The first Mars rover.
You mean like Curiosity? Yes, Curiosity bounced because it was in a big giant balloon.
It bounced and then went back. Did it bounce off the planet?
No.
That's the only point I was making.
I'm just wondering if you're going to try to figure out a robot that had paddles and shoot people into space like it's a ping pong game.
That can happen too, bro.
All I'm saying is
Big giant slingshot. We're going to shoot people to Mars.
Is a much less dense object.
I didn't say the moon. The moon's not a planet. I said planet.
Okay.
What?
No, you said Mars though. So yeah. So he said whatever. At the same point, the gravity's not the same.
Yeah, we agree on that. There's no disagreement on that.
Yeah.
We're on the same page.
So I'm saying the fact that it bounces, that doesn't mean that's
unless
a product
you were being
of the mass and the contents of that atmosphere.
So I'm not arguing the physics.
Yeah.
I'm arguing what you said. You said it would bounce off the planet. That's
well,
the
I'm
argument.
saying I was taking hyperbole because you're saying you're just gonna drop it from space or wherever in the air.
No. So
And
that's the misconception. That's why I was saying it was in the atmosphere. So I'm assuming in the atmosphere,
You could be in the atmosphere
mean that's
5 feet
not in
up,
that.
1,000 feet up.
Well, I didn't mean the
20,000
stratosphere.
feet up.
I'm saying if you're in the atmosphere, I'm assuming you penetrated the planet and you're actually inside
The stratosphere is
clouds.
also
Yeah,
an atmosphere.
inside the clouds. So are the clouds in the stratosphere?
I mean, yeah, there's clouds in all of them.
Yeah, but I'm saying like, at some point you penetrate the clouds, right?
Well, so there's a clear difference between where it's the gravitational pull is what you're referring to. If you're past, now you're getting in orbit, or you're getting pulled to the planet.
So like I said, once again, I'm gonna say it this way so you understand. You are 100 foot.
There you go.
That works for you?
There you go.
1,000 foot.
Yeah,
Okay.
I'm just.
There we go.
I'm just trying to tell
now
you.
we good. Now we good.
Aren't you
Because
glad you
if
didn't
you
start that all
thought
planets have
if
freaking
you thought
clouds?
that I thought that you could take
It's
something,
exponential, man.
you thought somebody could take something, or I thought somebody could take something and drop it from the wherever outside the orbit of a planet and think that it was going to go on the planet. No, that's retarded.
Yeah, well,
Because
listen,
it's not
Mentally
going to do that.
challenged.
quantum tunneling is also a thing, so it could be through the planet. So yes, there's a lot of things that could happen.
I'm saying if I drop something, it's an orbit, right? That thing is going to orbit that planet.
If you drop it with no
that's what I mean.
spin, it's free fall. There's a lot of
You're
things.
welcome. We finally got our physics talk.
No, this guy's talking.
I'm just wondering how.
You can't just neglect all these extra forces, though. I'm just saying.
I'm just wondering when have not every planet has clouds.
Hey,
Concept.
look, you're welcome. We finally.
There's no atmosphere. Yeah, of course.
We
just
finally.
at the planet.
We finally had our physics talk.
You know, next thing we talk about is how Saturn's freaking clouds aren't toxic.
I just try to let you know there's a big difference.
No, we on the same.
1,000 to 100, whatever thousand.
We on the same page. I did not give enough data points.
Yeah.
I gave you the data points you need.
Kinetic energy.
This is how you know somebody works in maintenance.
Yeah, right.
I gave you.
He gives you half the information, and you got to figure out the
Okay,
rest.
we're off the point.
Well, I mean, I'm saying if you go through the clouds, I mean, how far are the clouds outside the
Depends.
the planet?
It depends.
The
You have cloud that
clouds
goes
are
all
here.
the ground.
The clouds are here. Off the planet is here, right? How
I'm
many
gonna send
how
it
many miles are the clouds from the
Oh.
planet? Here,
It's
right
a
now.
lot. It's a lot.
About 3,000 feet.
It's a lot.
That's okay. Now let's go. We're done.
It's
Hey,
more than
by the way,
3,000
we did
feet.
get the physics talk.
It's more than
Hey,
3,000 feet.
STEM.
STEM.
That was STEM.
It's more than 3,000
You
feet.
explained some
It's
stuff
like,
to me. I learned,
I'm telling
and
you.
I gave you some scenarios that you didn't
Well, it depends
quite
on you talk about
that you
3,000
that you
minutes.
didn't quite.
I didn't like it because you're
Understand.
breaking the laws of conservation of energy.
Okay, well, I gave you some. You had to explain it to me, so I understood.
Bounce off the planet.
You said that, not me. You said
He's
it.
gonna do the old skipperoo.
But anyway, let's go. All right, let's move on.
Hello, Apollo.
Someone's gonna give.
He would
Okay,
fail
so-
that one. But okay, now we
Now you
get-
got to compare both, or you. Or
Yeah,
you already,
that's what I'm
I
working
guess you
on.
did- yeah, they go.
But yeah, before we decide to go down that rabbit hole,
No, we
We should stop that.
you know,
we
we'll
good.
eventually find the bottom of that well. But you know, the thing is we had Bright Minds at, like I said, at Rapid, and you know that's the STEM wing of SME. We also saw that we had the Bright Minds, the Bright Minds set up, at South Tech. They were there. They were doing I guess a scavenger hunt through the entire show, and also that Friday they did a scavenger hunt. The last day they did a scavenger hunt, and then they were able to win like a 3D printer or something like that for their classroom or something crazy. I think Rapid was a 3D printer, and I think they did a 3D printer for South Tech as well. But they also let these kids listen in on some of the the conversations. South Tech, you saw them bring in the guys from the Titans of CNC guys, from their academy that they've got. If you haven't checked that out, it's freaking awesome. It's free. You can buy all things to learn how to use a CNC machine. But Rapid didn't see that. They don't, because you don't really have anybody who is the Titans of CNC for Titans of 3D printing. They're getting to it because I see Titans of CNC is working through an additive manufacturing side of the house. But the thing is one focused on like geometric shape. Teaching the fact that, hey, guess what? We're gonna do material science. So their STEM related side of the house as far as Rapid was material science. While at South Tech, it's more or less material removal. It's how do I use this material to cut through this other material?
Yes,
for example, it's also the fact that you start. The thing is, you start playing with each other. You start about wire ADM. Wire ADM works perfectly fine inside additive manufacturing and not additive manufacturing. Subtractive, because it's just a piece of copper that cuts through Iconal steel. It's one of the hardest steels on the planet. As far as that is able to be machined right now, besides titanium. But the thing is then you get into like what you said, the guys, the different companies that were at South Tech that made it a little bit more enjoyable when you had those STEM conversations. You had the guys from Phillips Haas that were willing to have those conversations with you, and I talked to you about like Toolpath and stuff like that, and how the Melt.io system worked alongside theirs. Then you start talking to the guys over at CAD-CAM, Kevin and his team at CAD-CAM, where they talked about how they take the chips and turn the chips into heat and get rid of that to cool down everything else. But he also talked about the tool paths, and really got into the science behind the tool paths, the math behind the tool paths. Everything takes math. But then, like what you said, we get to Yaskawa. That was really the only company right now that I've seen that pushes the STEM envelope. That says, hey, guess what? We're here, whether you like it or not. You know them from their drive motors, Moto Man and their teams. You also have the Moto Mini, which is, I guess you can say, what, a backpack size robot. You've heard Trunk Monkey, now you get Trunk Robot. But then you get probably one of, if not one of the best, I guess you could say, types of things that we've seen for when it comes down to STEM education is the MotoSim, where we can actually teach people how to program robots in real time, but without the need for a robot. They get the actual, teach Pennant, and they actually get the software so they can actually program a robot in a environment that's safe for them and safe for the people around them. So for me, we did see a couple other, like, hey, this is how we do additive manufacturing simulation. But I wouldn't really count that as too much STEM. But then you also have the guys who are doing the OT training in their I think it was CYMMI. They have a training bus that they use to do all the training in. But Yaskawa is probably, I guess you'd say, when it comes down to the total package for STEM education, I think they would pretty much be it.
Yeah, so I think basically they use offline programming, and like offline programming is pretty much the standard for most integrators doing their initial set up, and then they'll touch up paths once they're on site with the actual equipment. So, but they were able to take the pendant as opposed to this just being a keyboard and a mouse.
Mm-hmm.
So that's they have what's called a virtual pendant that basically you can open up as a piece of application, and you can click on it and tell the robot to do different things. But to add the pendant where the person can actually use the pendant and move it around, you could even get creative and do it kind of like they use Flight Simulator School for pilots and have a big enough screen that is real size.
Yeah.
And then one for one. Yeah, so I mean, that's some of the things that you could
Private pilot robot.
Yeah. So yeah, I would say too that was pretty. It was pretty compelling to me because, like I said, I've been doing robotics for I don't know about 15, 20 years.
What's the quickest way to learn something? Is to immerse yourself in it.
To be able to have that pendant in your hand, it's a game changer because you get to push the buttons and stuff. And like a lot of times when you're out there, say on the shop floor,
you don't have a real system to work on, and you're scared to touch a production system.
Right. And so now I can take this and don't worry about messing up or crashing because I can do all this and learn how to do those things. I can even take my environment, put it back into this software, and then be able to say, hey, let's go do a fire drill for recovery.
What happens
the robots.
when this happens? Yeah, exactly.
And they also have the smart pendants now. You know, the smart pendant where you turn left, right, and the robots go left, right.
Mm-hmm.
You know, and stuff like that. You know, we did see some stuff, you know, going back to Rapid where it's like, hey, guess what? You're printing things at, you know, ginormous size here. And
they're using robot arms.
Right, you're using full robot systems. So, the both environments kind of go hand in hand. You know, both shows go hand in hand. Because it shows what's the next frontier. You know, we know that we're using robots now for the building of, you know, cars, planes, trucks, you know, who knows what else. But then you have the same robot who is out there building the hull of ships or boats out of manufacturing, or parts for sailboats, or houses, for that matter. Now with the fact that we're able to 3D print concrete.
Yeah.
So
we even saw one that was they used a small robot to do pottery.
Yep. And the thing is now if you learn robot, if you can take the Moto Sim, you know, side of the house, and roll it all the way through, you can actually hit every single piece. So you easily understand what's going on. But you know, the thing is that's not to take away from the fact that both shows were absolutely amazing. SME does a great job with making sure that their point is across. The kids are taken care of. The people are taken care of. It's a great show. Good people at both. You know, a lot of information exchanging hands and, you know, exchanging minds. And it's just how they do things. You know, the thing is we can't pass up the announcement that they made, like we talked about, you know, last week. And we're gonna have a video that we're gonna post here in a little bit. I gotta still work through. That is about the announcement, you know, that SME made. You know, we gotta keep that in mind. We're pushing the next envelope of STEM because kids aren't getting enough. So,
well, I think one thing to consider, and I think John could probably talk on this, though, there is an aspect to additive manufacturing that we're maybe not focusing on a little bit. They're able to make, I forgot where I saw it, I forgot the exact company, excuse me guys, but there was a company that used a 3D printer to come up with a different design for or it may have been a university, come up with a different design for a propeller. So one of the things that we're seeing with this revolution in additive manufacturing is allowing some design things that you cannot always do in a CAD CAM, or it's almost impossible to manufacture these things with the current technology we have, without other than additive. Like additive is it,
right?
You know,
It's
so
the quickest way.
yeah. So I think that's one thing is teaching future engineers how to think a little bit out of the box and use some designs that maybe from what we have far as like CNC technology or welding technology, it's not possible.
Mm-hmm.
Yeah, I mean, like we as a nation have to break away from the making kids fill out a packet of like worksheets to do work. And some kids love to do that because they can get through it quick and answer the questions fast. But filling out a packet's not going to teach you nothing. It's not going to teach you how to read a graph. It's not going to these are some of the basic kind of things that you need to get anywhere in understanding change, understanding how things work, how things behave. I mean, it's hard to say where it starts, but we're curious from a very young age already. So we definitely are lacking in a lot of some of that additive manufacturing, like making something from nothing. You know, that mentality isn't happening enough. So I would say, like, yeah, we need more focus on not just additive. Subtractive is still just as important. I mean, it uses the same G code and the same, like, you know, pathing for a lot of the tools and the tool heads. So for me, like, it just makes sense to do these things. And to me, I'd almost say it's required for you to think that, you know, if you want to think outside the box, you almost have to do without for a little bit and try to make ends meet. Or you have all the pieces you need to put a puzzle together. I still do puzzles to this day. So it's something where I'm like, oh, 1,000-piece puzzle. That's like, all right, I'll do that while I'm eating my lunch. Like,
I'm not gonna do it.
Don't do it.
No, you know what I mean.
What's that?
I was gonna go down a rabbit hole.
Oh, okay, good. But yeah, no, that's so like when you bring it up, like the focus on STEM, I think that it needs to be there. So I mean, I see what these guys are doing. If you gave me a simulation of a robot and you could tell me that my robot's in real time, like I have a projector, is gonna move, and it's like, okay, who can get the robot to dance first? Like that would be something that like would blow a kid's mind, and they wouldn't stop thinking about that.
Robot programming competitions, that'd be kind of interesting.
Yeah, they would. It would be a core memory that they would remember, that they would think back to as, like, I mean, at a young age we had to decide what we wanted to do very early at like 18, 19 years old. So if I remembered, hey, when I was 13 I saw a robot do a cool little dance, we had a competition, it was pretty fun, I won that, so maybe I should stick with this. You don't get that same experience if you don't see the robots, you aren't involved with it. I mean, even let's take away the STEM piece and let's talk about in the field, right? Let's talk about someone who is also a trained expert in the field with you. They just started the job, that came from another company that was competitive to yours, right? They're not going to be able to get up and running that quickly. There's still going to be some type of like learning that needs to happen. And we talk about not wanting to touch a productive system. When is that going to happen? It's not going to happen. So you need something virtual. You need something that's not connected. You need something that's, you know, for you to trial or test. So.
Yeah. And it's the first time I've seen that in the big three, I'll tell you that.
Yeah, it's almost a necessity at this point to have some type of environment like that. And if you're talking about the pendant works the same as like if I was in a live production system.
It's the same as that when you had attached to the robot anyway.
Yeah, if we start, like, we talk about it, I mean, this is how we can get the kids 20 years experience before they get to 17. No, but you start teaching them early, right? Yeah.
So I'll just say this: you get them the fundamentals, so when they go to learn, the more. Yeah. That when they learn the problems they're going to see in the actual environment won't be the actual problems that they had.
And they won't freak out because they've seen it before. They like, it's even if I mean, we learn it all the time. Sometimes you make the wrong call. Tough. But that's why you have a backup plan. Right. The backup plan cleans up the mess. Yep. Okay, it may not be a quick process, but that's what it's there for. Then what do? You're gonna just stop trying? Yep. No, you're gonna have to try again. So,
but as far as the 20 years you're talking about with AI and machine learning, when it actually get to a point that we can get some data that we can count on.
Let me do some scary stuff.
Then yeah, you'll be able to do the machinery itself will be able to kind of compensate. It'll be a
coexistence
together, basically.
It'd have to be, I think.
Yeah. I think that's somewhere in the future, but I think one day that'll probably happen.
Yeah, that's fine. And I think that we're on the right road. I think we are definitely almost there. where we have, say, education, agnostic, where it's, we can teach everything in, every grade level.
That's the key.
Yeah, because I'm a little mad I didn't get shop class when I was in school.
It's like,
that's so healthy.
when you get into the fact of, it's like, I want to be able to take one idea and teach it all the way through. I want to start at kindergarten where these kids are just, learning what a teach is. And get all the way to the fact that these kids are now in high school going, oh, I can program a full robot now. And, because I stayed in robot class or club or something like that. And, they got hands-on with the stuff. And the thing is I'll tell you this, Yaskawa and their Moto Sim is the great way to hit that point. And, their family of brands. I think is one that can definitely do that. Along with the fact that you can do Robot OS and actually build your own robot, which is actually kind of cool because their SDK lets you point some of their stuff to Robot OS using their other stuff they've got. So, I think, for us, I think we've kind of, rode that dead horse a little bit. But we went a couple of rabbit holes. I'm sure we'll do it again. We're already getting ideas of what our next week's episode is going to be. I think we pretty much got that idea down pat.
Ed's dropping a basketball from the stratosphere.
Basketball, a 3D printed.
Okay, the airless basketball. He's dropping it from the stratosphere.
Yeah, we'll talk more about it. We're not going to go down the rabbit hole. We'll talk more about it.
But, in the grand scheme of things, I just want to say thank you, and I want to say thank you to everybody who's tuned into this, who's made these trips possible, who's made, the memories, enjoyable, the ones who we've talked to outside of this. We want to say thank you. We have had, some good news in the past, little bit. And that is the fact that we have officially crossed the 2,000 listener mark, the 2,000 download mark. We had 2018, as I'm looking at it right now, actually. And, we're holding strong, and the thing is we're in, some other new areas. No, we were there before. But, we're happy with that, getting everything out there, getting everybody have some fun with it. And, if y'all have any ideas when it comes down to, like STEM stuff, send it over to us. But, go take a look at Printed Heritage. Go take a look at the blog. We'll definitely be getting more involved there. Go take a look at vulcanart.com. We're going to be a little more active. Hopefully we'll get revamped the website here in a little bit. Got that to do. And also take a look at the YouTube channel. We'll be releasing a video about the STEM announcement here shortly. But, I want to say from my side, thank you. We appreciate you. We hope to, meet some of y'all soon. And, y'all have a good one. I'm going to turn you over to the guys.
So, like I said, we appreciate all the support. We appreciate all the listeners that are, enjoying the content. So for me, I really am passionate about STEM, but I have my ideal of what STEM and how STEM should be done. I believe in systems. I believe if you could teach people how to do systems, and then those systems can be built upon. So if I can take a system and use that system to use in the future. So I think that's one of the biggest things that we can do with STEM. And it doesn't have to be just for manufacturing. It could be for somebody that's curious, from anything from designing a solution for somebody that has a missing limb. So I think it's a lot of applications that STEM can actually improve the world. So like I said, I appreciate the help for you guys listening to us, and thank you.
Yeah, so same thing. I always echo. Very appreciative. Thanks for letting us hit that mark. Thanks for listening. Stay tuned. Keep listening. But also on the same point, if you guys have any questions, check out that 3D or Vulcanara 3D or Vulcanara Technology Solutions website. Send us any questions. Check out Printed Heritage, all those good things. If you've got some suggestions or some questions, you think you see something lacking, you have any pointers, just let us know, guys, so we can kind of make that experience better for you guys, though. But stay tuned. We've got several things coming through, and we look forward to seeing you on the next ones.
All right, y'all. Have a good one.
That's all for this episode of Tech at Lunch. Thanks for tuning in and joining us for this tech-filled lunch break. We hope you enjoy the show, and don't forget to subscribe on all channels. And also, you can find us on YouTube under Vulcanar Technology Solutions. And join us for our next episode, which gets published every Wednesday at 8 a.m. All right, y'all. Have a good one. We'll see you later.